The dwarf planet Pluto has 5 moons down to a detection limit of about 1 kilometer in diameter. In order of distance from Pluto they are Charon, Styx, Nix, Kerberos, and Hydra. Charon, the largest of the 5 moons, is mutually tidally locked with Pluto, and is massive enough that Pluto/Charon is sometimes considered a double planet. History. The innermost and largest moon, Charon, was discovered by James Christie on June 22, 1978, nearly half a century after Pluto was discovered. This led to a substantial revision in estimates of Pluto's size, which had previously assumed that the observed mass and reflected light of the system were all attributable to Pluto alone. 2 additional moons were imaged by astronomers of the Pluto Companion Search Team preparing for the New Horizons mission and working with the Hubble Space Telescope on May 15, 2005, which received the provisional designations S/2005P1 and S/2005P2. The International Astronomical Union officially named Pluto's newest moons Nix and Hydra, on June 21, 2006. Kerberos, announced on July 20, 2011, was detected using NASA's Hubble Space Telescope during a survey searching for rings around Pluto. It was first seen in an image taken with Hubble's Wide Field Camera 3 on June 28. It was confirmed in subsequent Hubble pictures taken on 3 and 18 July. Styx, announced on July 7, 2012, was discovered while looking for potential hazards for New Horizons. Charon. Charon is about half the diameter of Pluto and is so massive that the system's barycenter lies between them, approximately 960 kilometers above Pluto's surface. Charon and Pluto are also tidally locked, so that they always present the same face toward each other. The IAU General Assembly in August 2006 considered a proposal that Pluto and Charon be reclassified as a double planet, but the proposal was abandoned. Small moons. Nix and Hydra orbit Pluto at approximately 2 and 3 times the distance of Charon, Nix at 48,700 km and Hydra at 64,800 km from the barycenter of the system. They have nearly circular prograde orbits in the same orbital plane as Charon. Hydra is sometimes brighter than Nix, suggesting either that it is larger or that different parts of his surface may vary in brightness. Their sizes are estimated from albedos. If their albedo is similar to that of Charon, then their diameters are 46 km for Nix and 61 km for Hydra. Upper limits on their diameters can be estimated by using the albedo of the darkest Kuiper belt objects. These bounds are 137 ± ± 11 km and 167 ± ± 10 km, respectively. At the larger end of this range, the inferred masses are less than 0.3% that of Charon, or 0.03% that of Pluto. Kerberos has an estimated diameter of 13 to 34 km and is located between the orbits of Nix and Hydra. Kerberos has a much lower albedo, approximately 0.04, than the other moons of Pluto, which is difficult to explain with a giant collision. Styx is believed to have a diameter of between 10 and 25 km and orbits Pluto at a distance between Charon and Nix. Characteristics. The Plutonian system is highly compact and largely empty. Moons could potentially orbit Pluto at up to 53% of the Hill radius, the stable gravitational zone of Pluto's influence. For example, Psamathe orbits Neptune at 40% of the Hill radius. In the case of Pluto, only the inner 3% of the region where prograde orbits would be stable is occupied by satellites, and the region from Styx to Hydra is packed so tightly that there is little room for further moons with stable orbits. An intense search conducted by New Horizons to July 1, 2015 confirmed that no moons up to approximately 15 times fainter than Styx exist outside of Charon's orbit. Further information is expected as more sensitive data from the New Horizons flyby is sent back to Earth. The orbits of the moons are confirmed to be circular and coplanar, with inclinations differing less than 0.4 degree and eccentricities less than 0.005. As seen from Earth, these circular orbits appear foreshortened into ellipses depending on Pluto's position. The presence of Nix and Hydra indicates that Pluto could have a variable ring system. small body impacts can create debris that can form into a ring system. However, data from a deep optical survey by the Advanced Camera for surveys on the Hubble Space Telescope, by occultation studies, and later by New Horizons suggest that no ring system is present. Resonances equals, Styx, Nix, and Hydra are in a three-body orbital resonance with orbital periods in a ratio of 18:22 and 33 seconds. The ratios are exact when orbital precession is taken into account. This means that in a recurring cycle there are 11 orbits of Styx for every 9 of Nix and 6 of Hydra. Nix and Hydra are in a simple 2-3 resonance. The ratios of synodic periods are such that there are 5 Styx-Hydra conjunctions and 3 Nix-Hydra conjunctions for every 2 conjunctions of Styx and Nix. As with the Laplace resonance of the Galilean satellites of Jupiter, triple conjunctions never occur. All of the outer circumbinary moons are also close to mean motion resonance with the Charon-Pluto orbital period. Styx, Nix, Kerberos, and Hydra are in a 1-3-4-5-6 sequence of near resonances, with Styx approximately 5.4% from its resonance, Nix approximately 2.7%, Kerberos approximately 0.6%, and Hydra approximately 0.3%. It may be that these orbits originated as forced resonances when Charon was tidally boosted into its current synchronous orbit, and then released from resonance as Charon's orbital eccentricity was tidally damped. The Pluto-Charon pair creates strong tidal forces, with the gravitational field at the outer moons varying by 15% peak to peak. However, it was calculated that a resonance with Charon could boost either Nix or Hydra into its current orbit, but not both. Boosting Hydra would have required a near-zero Charonian eccentricity of 0.024, whereas boosting Nix would have required a larger eccentricity of at least 0.05. This suggests that Nix and Hydra were instead captured material, formed around Pluto-Charon, and migrated inward until they were trapped in resonance with Charon. The existence of Kerberos and Styx may support this idea. Rotation equals, Nix, Hydra, and possibly Styx and Kerberos rotate chaotically. According to Mark Showalter, author of a recent study, Nix can flip its entire pole. It could actually be possible to spend a day on Nix in which the sun rises in the east and sets in the north. It is almost random looking in the way it rotates. This is because they are in a dynamically changing gravitational field caused by Pluto and Charon orbiting each other. The variable gravitational field creates torques that make Nix and Hydra tumble. The torques are increased because the moons are elongated and not spherical. Only one other moon, Saturn's moon Hyperion, is known to tumble. Origin. It is suspected that the Plutonian satellite system was created by a massive collision, similar to the Big Whack believed to have created the Moon. In both cases, it may be that the high angular momenta of the moons can only be explained by such a scenario. The nearly circular orbits of the smaller moons suggests that they were also formed in this collision, rather than being captured Kuiper belt objects. This and their near-orbital resonances with Charon suggest that they formed even closer to Pluto than they are at present and that they migrated outward as Charon got into its current orbit. The color of each is gray, like Charon, which is consistent with a common origin. Their difference in color from Pluto, one of the reddest bodies in the Solar System, is thought to be due to the effects of sunlight on the nitrogen and methane ices of its surface, may be due to a loss of such volatiles during the impact or subsequent coalescence, leaving the surfaces of Pluto's moons dominated by water ice. Such an impact would be expected to create additional debris, but these must be relatively small to have avoided detection by Hubble. It is possible that there are also undiscovered irregular satellites, which are captured Kuiper belt objects. List. The Plutonian moons are listed here by orbital period, from shortest to longest. Charon, which is massive enough to have collapsed into a spheroid, is highlighted in light purple. Pluto has been added for comparison. The maximum distance between the centers of Pluto and Charon is 19,571 plus or minus 4 kilometers. Scale model of the Pluto system equals. Exploration. The Plutonian system was visited by the New Horizons spacecraft in July 2015. Images with resolutions of up to 330 meters per pixel should be returned of Nix, up to 780 meters per pixel of Hydra, and better than 2 kilometers per pixel for Styx and Kerberos. Notes. References. S. A. Stern, H. A. Weaver, A. J. Steffl, M. J. Muchler, W. J. Merline, M. W. Buey, E. F. Young, L. A. Young, and J. R. Spencer, Characteristics and Origin of the Quadruple System at Pluto, Nature, submitted, Steffl J, Muchler M. J, Weaver H. A, Stern S. A, Durda D. D, Terrell D, Merline W. J, Young L. A, Young E. F, Buey M. W, Spencer J. R, New Constraints on Additional Satellites of the Pluto System, Astronomical Journal, submitted, Buey M. W, Grundy W. M, Young, E. F, Young L. A, Stern S. A, Orbits and Photometry of Pluto's Satellites, Charon, S/2005 P1 and S/2005 P2, submitted, Brzezowicz, M., Showalter, M. R., Jacobson, R. A., and Buey, M. W., The Orbits and Masses of Satellites of Pluto, Icarus, 246, 317 IAU Circular Number 8625, describing the discovery of 2005 P1 and P2, IAU Circular Number 8686, reporting a more neutral color for 2005 P2, IAU Circular Number 8723 announcing the names of Nix and Hydra. Background information regarding our two newly discovered satellites of Pluto. The website of the discoverers of Nix and Hydra. External links, animation of the Plutonian system, Hubble spots possible new moons around Pluto, 2 more moons discovered orbiting Pluto, New Horizons mission site.